Okay, looks like most people are here. I'm just setting up the live stream to go up, and then once that's up, we'll get started. So let's take up example 3 from the cosine law yesterday, and then we're going to take up some of the review questions. I saw some people posted some things in chat, which is great. So I saw question 4, 2, and 6. Okay. If you have any other questions specifically you want me to take up, please let me know. All right. But let's get started with this. So example 3 of cosine law, we set it up with the triangle being able to identify, right? It says that Ken's cell phone detects 2 transmission antennas, one 7 kilometers away and the other 13 kilometers away. So what I highly suggest starting off with is draw Ken. Draw where Ken is, right? And so for me, I put Ken at the top, and then I put one transmission antenna over here and the other one over here. And I said they were 7 kilometers and 13 kilometers away from Ken. And then they are separated by an angle of 180 degrees. So this is the information that we have here. And it asks us how far apart are the two antennas to the nearest kilometer. And so that's the distance across between the two antennas. And as I label the triangle with capital A, B, and C, we are looking for side A, essentially in our diagram, right? This length between these two antennas. So now that we have this information and we're solving for a side length, we can use our side length cosine law equation. So A squared equals B squared plus C squared minus 2BC cosine of A. So this was our formula here, and we can plug in our values. Lowercase b would be 13, lowercase c would be 7, and then we plug that into BC over here as well using brackets, and then cosine of A and angle A is 80. So you should have gotten up to here plugging in all the values that are required within our formula and then starting to calculate that. So when we start to calculate that, 13 times 13, we get 169. 7 times 7 is 49. And then we do this multiplication here. 2 times 13 times 7 is 182. And then cosine of 80. We then said, okay, the next step to make sure our math is step by step and we don't make any mistakes, we add 169 plus 49, which gives us 218. And we do 182 cosine 80, which I will bring up my calculator here. 182 times cos 80, so 80 cos. And that gives me 31.6. Subtracting that, 218 minus 31.6 gives me 186.4. And then I square root both sides to get rid of the square. And that's going to give me my final answer. So 186.4, square root that, and I get 13.7. Which, of course, to the nearest kilometer is rounded up to 14 kilometers. Right, so it's approximately 14 kilometers. So we write our therefore statement. Therefore, the two antennas are approximately 14 kilometers apart. And there's our final answer for this. So that was example 3 that I asked you to do yesterday, and just taking this up here. Any questions on this one or any points of clarification you would like? Speak now or forever hold your peace.
Number 6.
Oh, no, I mean for this example specifically.
Oh, never mind.
Okay, so then let's dive into our review questions. And yes, I saw it. So 1C, question 2, question 4, and question 6 were the ones that were brought up. So we are going to take those up here. Where is my Unit 5 review? Where did it go? Hold on. Oh, give me 1 second. Okay, there we go. Got it. All right. So practice tests for Unit 5. We have trigonometry here. The answers were on page 4 if you needed it. So 1C here. So question 1 was all about SOHCAHTOA. 1C. I think you guys are having difficulty because the triangle is sideways, but it doesn't really make any difference. So let's go through this one here. This is our angle that we have. The first thing that we always do is to identify the hypotenuse, which is across from the 90-degree angle. So here's the hypotenuse. We then have our adjacent here, and then our opposite here. And it's asking us to find the hypotenuse. So which one would we use? Should we use sine, cosine, or tangent? Cosine is correct. We have adjacent, we want hypotenuse, and the only one that has both of them in the formula is cosine. So for us, I'm going to zoom in a little bit here. So cosine theta is equal to adjacent over hypotenuse. Plugging that in, we're going to get cosine of 45.3 is equal to adjacent, which is 2.5 over y, because we're solving for y here. Now from here, if we're trying to isolate for y, there's a two-step that occurs. I'm just going to go into it right away, which you should be able to rearrange it to get this. Okay? And for those that are like, I don't know how you got that, let's do our in-between step here, which you should get y cosine 45.3 is equal to 2.5. I'm running out of space. Hold on a second. Let me shift this over just a little bit. Okay, so what you should get here is y cos 45.3 is equal to 2.5. If you move y to the left side, for example, like this, like this, that's not isolated. So you need to divide cosine out, right? And by dividing cosine out and moving it to the other side, we get it at the bottom of the fraction because it's multiplying. And that's going to give us our final answer, which leads into y is equal to, and we do the math here, 2.5 divided by cosine of 45.3, and I get 3.55 or 3.6 to, since it's to 1 decimal place. Okay, so any questions or clarification on this one? Just because the triangle is sideways doesn't make a significant difference, but the math, you got to be careful. If the variable is at the bottom, right, they switch positions, like these two switch. That's another way you can think about it. Okay. So I'm glad that helped clarify some concepts here. Question 2 was the next one. Draw the triangle, then find the lengths of all unknown sides to 1 decimal place. And then it says, oh, angle A is 90, angle B is 11.7, and side B is 11.9. Okay, sure. So if we draw a triangle, well, it told us that one of our angles is 90 degrees. So we should draw a 90-degree triangle. I'm going to draw something like this. Boom. I'm going to label it. A is, oh, those are triangles. A is here, and B and C can go anywhere. So I'm going to say this is B and this is C. And using the information given, that tells me that this is 11.9 here. This is 90 degrees. And this angle here is 11.7 degrees. You should start off with a triangle that looks like this. Maybe you drew your triangle the other way, right? Maybe you drew it like this. I don't, like, once again, it doesn't matter the way you drew your triangle. What matters is, the key points here is A is 90 degrees. Angle B is somewhere. That says 11.7 degrees. And side B is across from that. And then when we label this, we get hypotenuse, adjacent, and opposite, according to angle B. It's asking us to find all the unknown sides, so you can do trig twice if you would like. That is an option, right? You can use sine law if you wanted to use sine law here, right? Because sine law works for 90-degree triangles too. It's up to you how you wanted to target this, because I did not specify which one you were to use. I'm just going to use SOHCAHTOA, make my life a little bit easier. So first I'm going to solve for side A, which is our hypotenuse, right? That's side A. So I'm going to say I have opposite, so I'm going to use sine theta is equal to opposite over hypotenuse. And that's going to give me sine 11.7 is equal to opposite, which is 11.9, divided by lowercase a. That's our hypotenuse. Which allows us, once again, this is that same idea. We're going to have to switch their positions, and you get a is equal to 11.9 divided by sine 11.7. And that's going to give us our a value here. So 11.9 divided by 11.7 sine. And that gives us 58.7 centimeters. Okay. So that's going to be our first one here. If I'm solving for side C, since we have opposite and we want adjacent, I'm going to use 10 for this one. So it's going to be opposite over adjacent. And that's going to give me 10 of 11.7 is equal to opposite, which is 11.9, divided by adjacent, which is C. Same process. I'd like you to try solving this on your own if you haven't done so already. Find side length C. I'll give you a minute to do so. You just need to type it in on your calculator, essentially. And let me know what you get.
Sa angle 8 is 90. Hindi ko to siya gets, girl.
Okay. You should have calculated it by now. So you should have done 11.9 divided by 10 of 11.7. And I get 57.5. Any questions here?
Mr. Choi,
Yes.
is angle A 90 degrees? Or is the given
Yes.
in angle A 90?
Yep, it tells you right here, angle A is 90
Okay.
degrees.
Okay, thank you.
Okay, so these are the two side lengths you should get, and that's going to be the whole question here. Okay. So is my triangle drawing accurate knowing this? No, it should have been uh, something more on the lines of like this would be more accurate if I were to draw A, B, and C. But once again, you're drawing your triangle. As long as the labels are in the correct spot, I don't mind as much. Okay. Then we have another question here. That was question 4. The height of a mountain is 1 kilometer. The angle of depression from the top of the mountain to the bottom is 35 degrees. A trail runs down the length of the mountain. What is the length of the trail? Okay. So the height of a mountain is 1 kilometer. So you could draw a triangle like this. You can say, "Oh, this is my mountain," right? And then you say, "Okay, if that's my mountain, this is the height of the mountain." Let's say, right? We'll just say the mountain's symmetrical, and it's saying the height of the mountain is 1 kilometer. So this is 1. And it says the angle of depression from the top of the mountain to the bottom is 35. So for us, that means this angle here is 35 degrees. It also tells us another thing. Anyone know what other angle it tells us?
The inside of the triangle on the bottom.
Yes, on the bottom right, the inside of the triangle here, this is 35 degrees. That's the information it tells us here. And of course, since this is the height, as Ashley mentioned in chat for me, this is 90 degrees. Okay, so now we have our triangle that we're working with here, right? The angle of depression is just there to help us identify an angle inside our mountain triangle as well. In doing so, it asks us for the length of the trail. So let's label this triangle first, which is we'll do A, B, and C like this. And that means we're solving for side B here, right? I can erase this if I wanted to now. So now you can see the triangle that we're working with here. We're working with side B. We need to find that. So we should label according to angle C. This is opposite, this is hypotenuse, and this is adjacent. Since the question only asks for hypotenuse, and we have opposite, which one am I using? Sine, cosine, or tangent? Perfect, sine. Very good. So sine is opposite over hypotenuse, which gives us sine 35 is equal to 1 over b. Once again, solve for b. I'll give you another minute or so to solve it and try it yourself, and then we'll take it up. So rearranging it, you should get b equals 1 over sine 35. Hopefully you guys are calculating right now. So when you do b is 1 divided by sine 35, I get 1.74 or 1.7. So what is the length of the trail? The length of the trail is 1.7 kilometers long. Just like that. Yeah. All right. Any questions about this? I've noticed that all the questions that have been asked recently for me to take up from the first part was when your unknown, your variable, was at the bottom of the fraction. So hopefully this helps identify what you should be doing in case something like this happens. Okay? So hopefully that does
I have
clarify.
a question. If it's at the top, say the variable's at the top, you just like you put the number to the other side of the sign, right?
Yep. It's just multiplying, yeah.
So we only divide if the variable's in the bottom.
Okay. And then I think the last one was question 6 someone asked me to take up. So question 6, word problem here. Krista wants to ride the roller coaster called the Plummet. The peak of the roller coaster is 250 meters above the ground, and the length of the drop is 255 meters. The angle of depression to the track. Find the angle of depression to the track to the nearest tenth of a degree. Okay, sorry. So with the peak of the roller coaster 250 meters above the ground, length of the drop being 255. Yes, I know roller coasters look something like this. All right, I get it. But we're doing a really terrible rendition of this, and we're gonna force it to look like a triangle, and it's gonna look something like this. All right, it happens. Okay, what else are you gonna do? So essentially, if you were to imagine the track, just assume just assume like the roller coaster goes up like this, and then it's dropping, and then there's cars here with the roller coaster. It goes up. You know what I'm saying? It's approximated as approximately a triangle is what we're trying to go with, right? This whole unit is about triangles. Draw a triangle. With that being said, the information that we're given is that the height is 250 meters and the length of the drop is 255 meters. So the drop would be here, right? That's where the track would go. If there was like a coaster, it drops this way, like this. So once we have that, we know this has to be 90 degrees here because it's the height of the roller coaster. And it says, so find the angle of depression to the track to the nearest tenth of the degree. So the angle of depression here would be this, right? But where else is that present in our triangle? The angle of depression is equivalent to the angle of elevation. It's asking you to find theta here in the triangle. Once you find theta here, you find the angle of depression. And what is this? This is the Z rule, the Z pattern, right? When you have two parallel lines like this, you have this angle and this angle are the same, right? So we know the Z pattern, and that's why the angle of elevation is equivalent to the angle of depression. It's the same idea. If you are on top of the roller coaster and you're looking down at your friend on the ground, the angle at which you have to look down is equivalent to the angle your friend has to look up to see you, which makes sense. You're making eye contact, right? So that's kind of like the idea there. So once we have that information down, we're solving for theta. Well, let's label this stuff here. We have, if that's theta, this is opposite, this is adjacent, and this is hypotenuse. What do I use? Sine, cosine, or tangent?
Cosine.
Cosine? No. It is not cosine. We have opposite and hypotenuse. This would be sine. So sine theta is opposite over hypotenuse. When we plug that in, we have sine theta is equal to opposite, which is 250, over hypotenuse, which is 255. So we get sine theta is, if you want to do that as a fraction, you can. But, sorry, once you have it here, we said get rid of sine. We don't want it because we want theta alone, and to get rid of it, we do sine inverse and move it to the other side. And then we're going to sine inverse that. And you should get a pretty big angle. So 250 divided by 255, and we're going to sine inverse that, and we get 78.6 degrees. Therefore, the angle of depression of the track is 78.6 degrees. And that would be the answer to this question here. Yeah. Any questions about how to set this up or how we solved it? Right? Once again, I would say, once again, with a lot of these word problems, the difficult part is drawing it and setting it up. Once you have that, the math is a lot easier than you think, right? It was complicated at first because you're learning the new sine, cosine, tangent buttons and sine inverse, cosine inverse, tan inverse. Well, once you get comfortable with it, it's not too bad as you go through it, right? It's not too bad. So some of this here. Okay. Let's continue onwards here. We didn't get any questions for any of these ones down here. Did anyone have another specific question they wanted me to take up? Otherwise, I'm just gonna quickly go through, ask some quick pop-up questions here through a poll. So this is just to make sure that everyone knows how to understand, what to do for certain things here. What is going on? Give me 1 second. I'm setting up the polls here now. Ashley, I saw your number 10, so we will take up number 10. No worries. Okay. So we're going to do a couple polls here. So we're going to go all the way to question 10. We're not going to go in detail. I'm going to go in detail more on Monday as like a huge reminder for how we're going to do, right before the test. But what I would like to do and what's important to me is, can you start this question properly or these questions properly? Yes or no? So for example, for question 7, right? I want you to think about it and then tell me, after you draw it, or if you want to draw it right now, don't solve it, which one do I use? SOHCAHTOA, sine law, or cosine law? So for question 7, which method do I use? SOHCAHTOA, sine law, or cosine law? If you were to solve question 7 right now, which one would you use? Which method do I use? Okay, just another 15 seconds. Okay, and let's see. Overall, people said SOHCAHTOA, 4 people, sine law, 6 people, cosine law, 2 people. And then the rest of the people didn't respond. So if we were to draw this triangle here, right, it's a pyramid shape. We fill in the information. It says each slanted wall is 108. And it says the height is 70. And we need to find the angle of each slanted wall, which is theta and alpha. Or if you identified it correctly, this is an isosceles triangle. They're both theta. Should be the same. If you said SOHCAHTOA, you would be correct. If you said sine law, that would also be correct. Because you have your 90-degree angle, you can technically use sine law as well because there's an angle side pair. Cosine law here wouldn't really work as much because you don't have the correct like sides. You would need, for example, you could use sine law. It might be a little complicated though because that's not what you're solving for, like the angle you're solving for. So a little bit awkward to use cosine law to start off. So I would go with SOHCAHTOA or sine law here. Those would be your 2 choices for question 7. For question 8a, okay, I'm going to stop sharing those results here. Okay. And I'm going to relaunch it. For question 8a, number 8a, what do I use? SOHCAHTOA, sine law, or cosine law? All right, most people have put in their answer. Just another 8 seconds for it to hit a minute here. Boom. Sharing results. Most people said cosine law. 9 people on cosine law. 4 people on sine law. 4 people on SOHCAHTOA. The correct answer here, the only option you can do is cosine law. You can't use SOHCAHTOA. The restriction for SOHCAHTOA is that it must have a 90-degree angle. If it doesn't have a 90-degree angle, SOHCAHTOA is out of the question. Sine law here requires an angle side pair. There are no angle side pairs in this question for question 8a. So as a result, cosine law is the only one you should be using for this question to start off. Let's do it now for question 8b. Sine law, SOHCAHTOA, or cosine law? Once again, one of these answers is immediately wrong. 100% wrong. Okay, time's up. Once again, whoever did those four people who did SOHCAHTOA, you are not listening to what I'm saying. Do you see a 90-degree angle? No, you cannot use SOHCAHTOA. Okay? I literally just said that. You cannot use SOHCAHTOA unless you have a 90-degree angle. So those four people, you need to pay attention to my words. Okay? Sine law is the correct one. You do have an angle side pair here. 59 and 54. 59 degrees and 54 millimeters are the angle side pair. Cosine law would not work here unless you are solving for this side here. If you are solving for B, you can use cosine law because you have the angle, the side, and a side. As long as you have two sides and an angle or all three sides, you can use cosine law, but it would solve for angle B. But for us, since we were solving for the marked angle, I would go for sine law. So cosine law and sine law are correct. Sine law would be highly preferred, but you can use cosine law as well. Okay? The only incorrect answer would be SOHCAHTOA. That's the only one that is 100% not okay. All right? So let's keep going here. See how helpful this is, right? As we go through this. Let's relaunch. 9a. It's asking you to solve for side H, sine law, cosine law, or SOHCAHTOA. Another 5 seconds. All right. And with that, we have most people saying sine law this time, which is correct. We have an angle side pair, which means we get to find side length h using sine law. Perfect. Once again, cosine law, 2 people. You're technically not wrong. You can use cosine law, but actually in this case you can't. You don't have a side length. So actually the only answer is sine law. You can't use SOHCAHTOA. So you cannot use SOHCAHTOA here. There's no 90-degree angle. So that's crossed out. Cosine law doesn't work. We don't have two side lengths, right? Sine law, angle side pair. Done. Immediately, we can solve for that. 9b. Sine law, cosine law, or SOHCAHTOA. Another 10 seconds. We still have 6 people that have not answered. Okay. Progress. I'm liking this. No one picked Sokotoa this time. Progress. I like it. Thank you. No one picked Sokotoa. 9B. Definitely not. We don't have a 90-degree angle. Sokotoa is not being able to be used. Most people, majority, chose cosine law, which is correct. We do not have an angle side pair. We don't. Each side doesn't have its angle, or the angle doesn't have its side. So sine law doesn't work here. The only option here would be cosine law. Okay? Very good. So that pushes us on in towards the last question. Number 10. Two runners start at the same point at the same time. They run at constant speeds in different directions. So we start at the same point. Runner A runs north at 5 kilometers per hour, and runner B runs east at 8 kilometers per hour. And then it says determine the distance between the two runners after 2 hours. So there's our triangle here. Okay. Runner A runs north, 5 kilometers per hour, runs 60 degrees east of north. Oh, sorry. I read the question wrong. I apologize. 60 degrees east of north is the answer. So does anyone know what that means? 60 degrees east of north? I just completely misread the question the first time. What that means is 60 degrees east from the north direction. So actually the direction is around here, and this is 60 degrees, like that. So it does something like this. And it's asking for the direction between the two runners here. So if we say this is runner A, this is runner B, and this is the start, and we'll call it C here, right? A, B, and C. What's the distance after 2 hours? So my question to the class would be, how far did runner A run after 2 hours if he's running 5 kilometers per hour?
10.
10. 5 times 2 is 10. What about for runner B?
16.
16. Very good. So we have 10, 60, 16. Then, once again, last poll. Which one do I use looking at this diagram? Okay. With this, 11 people said cosine law. Cosine law is correct. There is no angle side pair here. 60 degrees, the angle side pair would be that AB. Doesn't have it. For 16, it would be angle A. We don't have it. And for 10, it would be angle B. We don't have it. So sine law does not work here. Okay? Cosine law is your only option. So my goal or your goal at the end, like as a class, when we come on Tuesday and we go through these polls again, I'm going to go through this one more time on Tuesday. Same thing we did in the morning of. We're going to go through each question. Tell me which one do I use. Everyone should get the correct answer. Right? That's the goal. That's how I know you've at least taken a look and studied the content here. Right? And that you're ready. Because once you identify which one you're using, the rest of the problem becomes simple. Right? It's just the math using the correct formula. So make sure you're able to do that here. So I'm actually going to have you guys do this on your own. I have set it up for you to get started in case you were stuck for question 10. But that is it for today. Don't worry, we will have a review session one more time the morning before the test. It should be like a 30-40 minute review session, and then we'll get started with the test. Otherwise,